Hello everyone, today I'm going to show you how to add semi-automatic self-setting ladders for your platformer. Let's say you created a character that can run, jump and shoot fireballs. But his or her life can become very miserable in a very short time when they realize that they can reach high places just because you invented this thing called gravity. To help your character, you can give him or her a ladder, for example. I will show you how I have done it in my game. So let us begin. But first of all, I will explain you what I mean by the ladders. The ladder is area 2D combined with static body 2D on top of it, and when player enters that area, his gravity is changed to 0. He's not affected by the gravity, he's not falling, and he can climb up and climb down. He will also be able to jump on the ladder, but when he's still pressing the jump key, he will fall down until he releases it or whatever. The ladders will be setting themselves automatically. All you have to do is to place them on the bottom of the ladder and set the number of tiles you want them to have. It will be done in ready function, so when your game level is loaded, everything will be working as it should. So let's make our ladder scene. Add a new scene, add 2D node, name it ladder, add area 2D and name it ladder area. You can name it whatever you want, but I'll try this, keep consistent, so this will be ladder area. Add a child to it, collision shape 2D, and rename it to ladder area collision. Set the shape to rectangle shape 2D. Scale it to be the size of your tile. In my case it's 16 pixels by 16 pixels. Next, add a child to a ladder node, and this time it will be static body 2D. Name it ladder top and add a collision shape to it also as a child, and set the shape to rectangle 2D. Scale it. Now you need to move your ladder area up, so origin of this ladder area is half of the size of the tile above the origin of our root node for ladder scene. Similar, the ladder top can remain in this position, but we need to, well, I can rename this also ladder top collision. And the ladder top can be just right here, but we need to scale it. Just like that. I'm changing the modulate value because I want to see it better. And that's it, that's our ladder. You can save this. I will save this as a ladder tut as tutorial, and let's add, actually let's add a script to it. So in our script for the ladder we'll need a few variables, so let's declare them. we want to know what will be the height of our ladder, so export variable ladder tiles, because we will be setting the height of our ladder in tiles. In my case, the default value will be 1. It will be 1 tile height. You can set it to whatever you want. It can be set later, and it should be set later when you are placing the ladder in your scene. Next, we need to know what's the tile size. So let's declare a tile size. In my case, it's 16 pixels. And we need to know the ladder to store the ladder height in pixels. So it's ladder height, and it's equal to ladder tile multiplied by tile size. Next, we need few helper variables. We need some references for our nodes over here. So already our ladder area is equal to this, on red. I will copy this 4 times because we need 4 of these. This will be for collision. This will be top. Well, you can leave those quotation marks. It doesn't really matter. Collision, and this will be top for top collision. As I said, when the ladder is loaded and ready in your game, we'll be calling a function that will set up the ladder automatically. So we will write a function called ladder setup, call it. So let's write the body of this function. At the beginning, we need to set the ladder's height, and it will be exactly what we wrote over here. So let's just copy this. Now we need to set the extents of our ladder. Rectangle shape 2D's width and height are the doubled values of extents, and setting extents is causing the width and height to grow or shrink from the origin point of our rectangle shape 2D. So to set the proper dimensions of our ladder, we will use our tile size and ladder height in pixels variables and halve them. So to shape the extent, to set the shape extents, we will use our helping variable shape extents is equal to vector 2 tile size divided by 2 and ladder height also divided by 2. I think we should store those extents in a variable, so let's declare one, ladder area extents, is equal to let's copy this, get extends. Now we need to set the right position, because now we'll have something like this. Revert those changes, because remember, this is the ground level, this is the ladder's bottom over here, and we are setting we set the height in tiles. So for example, we have 3 tiles, so we change the number of tiles like that, and the ladder is the position of this area is still in the same place, so we need to move this a little bit up. So let's do this, and this ladder area extents will help us doing this. So ladder area position on y-axis is equal to ladder area extends y-axis, but we need to move it up, so we need to take the negative value of ladder area extends y. Next we'll do the ladder top. We can also declare, we will not be changing the extents, we will be changing just its position. So let's declare helping variable, and this will be ladder top collision shape extends. Okay, and now let's set its position. Ladder top position y is equal to negative value, because we are moving it up, of ladder area ladder top extends y, and since so by moving ladder top by the value of negative top extends y, we will move it only here to the half of the height of our ladder. So we need to multiply it by 2, and also we need to extract the extents of our ladder top. So plus ladder top extends y. Let me explain this to you. So we set the position of our ladder top to the double value of extension of no, I just made a mistake. Area. Yeah, this should be area, because ladder top position. So we set the ladder's top position from here to the value of doubled extents on y-axis of ladder area collision, so it sits just right here, but we also need to move it a little bit down by the extent on y-axis of this ladder top collision, because so we need to move this like that, so it's not higher than the ladder area. You can see I have moved something. Oh, okay. So that's it for the ladder, and well, we can also set the ladder top collision one-way collision margin to something small. 0.1 will do. Oh, and I just forgot, we need to set this as a one-way collision, so you can see this arrow over here. And that's it for our ladder. Next we move to our player's code. As for your player, you will need a few nodes. If you don't have one, please add some raycast, rename it to your liking, and remember to enable this. Also, you will need to add area 2D. I will call mine detector, and I will add a collision shape to it and set the shape. I need to scale this. Remember, this shape has to be inside, placed over the collision shape of your player, but it can exceed on any axis, so place it inside and modulate it so it's more visible. Oh, I think center it, move it on the y-axis, so it's something like that. Just because I'm lazy and don't want to write it all over again, I tell you what you need to include in your character's code. First, declare a variable that will contain information if the player is currently on the ladder. It should be a boolean variable and its default value should be false. You may also want to declare a variable for the player's speed while the character is moving up the ladder. Climbing requires strength, so the character should move slightly slower than normal on the ground. For convenience, declare yourself variables that store references to the detector object and raycast. Next, you need a function that checks if the player is standing at the top of the ladder. For this, we'll use our raycast. In the function body, declare a collider variable and set its value to null. Next, we need to check if the raycast collides with any object. This is what the if statement is for. We are checking if raycast collides with something, and if yes, then we are assigning this object to collider variable. Now we can check if this object is actually the top of the ladder. We know that in our ladder scene the top of the ladder is called ladder top, so we can check if the string ladder top is in the name of the object that the raycast collides with. If it's true, we return true, otherwise we return false. I added the upper method here because I never remember if my object names are uppercase or in lowercase. To uppercase method changes given string to uppercase, so problem is solved. Next function will check in each frame if the character is within the ladder area. In this function we'll use our characters detector. We need to save colliding areas on a list. We can do this by using the getOverlappingAreas method, which returns a list of overlapping areas. Next, we check if the list is not empty, which means its size is greater than 0. If it's not empty, then we can check each element on the list using a for loop. One by one we are assigning each element to area variable, and we are checking if the string ladder is in area name. But we also need to check if the player is not jumping and he's not on top of the ladder. If those three conditions are met, then we can set the onLadder variable to true. If the list of the areas is empty, we can set onLadder to false. At the end of the function we can also return the value of onLadder. You never know when it will come in handy, and you can always delete this line of code. The jump function is simple. First, we are checking if the player is on the ground or on a ladder. If yes, then we check if he pressed the button for jump action. If yes, then we set onLadder variable to false, drop it to normal value, in my case it's 10, and we are applying jump action. Now we will deal with the function responsible for moving the character on the ladder. This is where you are going to have to fiddle around, because I don't know what kind of platformer controller you have chosen. But there are things you need to take into account. First, we need to check if the character is on top of the ladder and wants to go down by pressing the move down action key. Add that one to your input map and assign a key for it in the project settings. So, when those conditions are met, we set our gravity to 0 and onLadder to true. Now we need to move the character down. Well, we are not actually moving the character, we are just changing its position by a small amount. Next, we check if the character is in the ladder area. If so, we set the gravity to 0. Then we move the character up or down. If the character does not move, then we stop him. Next, we need to call our jump function. If the player is not on the ladder, then we set the gravity back to normal value. I also have this function which is responsible for moving my character to left and the right. This is where you have to call those two functions that we just wrote, jump function and ladder movement function. And also remember to call proper functions in your physics process function. So apply your gravity, check if the player is on ladder, and apply your movement. And I hope everything will work for you. I tried my best to explain everything. If you have any questions, feel free to ask. I will try to answer them. It will be actually much easier for me to answer in writing than talking about this, but yeah, I hope you like it and see you next time.